So let me tell you the trick with this problem. You just have to know what standard deviation is. If you know what this word means right here, the problem's a snap. And what I'm going to do is I'm going to take this data that we have. We have 5 different data sets, and each data set has 6 numbers in it. For each one of these things, let's just plot it. And when I say plot it, what I mean is we're just going to draw a picture. So imagine we have something like this. There's 1, there's 2, there's 3, there's 4, there's 5, and there's 6. Those are the numbers that are possible. And in this data set right here, that first one, what I can see is I've got 3 3s and 3 4s. So kind of a bunch of those. And in the next data set, I'm going to use these two to compare. See, I've got those same tick marks again. 1, 2, 3, 4, 5, and 6. And in that one, let's see, I've got 2 5s. I've got 1 2, not many of those. Okay, I've got 2 3s. And I've got 1 4. So here's what standard deviation means. It says how spread out is your data. And what you can see is in this one, right here, the first one that I drew, this is less spread out. There's simply not that much what we call variation in that. Whereas this one down here, that's more spread out. There's more variation, which means that has a higher standard deviation. Okay, that's kind of what we're getting at. Now I have a few more data sets. Okay, so this isn't the final answer. Let's see if we can do a little better. Which one of these things is going to be most spread out? Well, can you find anything? This is our current candidate for pretty spread out. This one clearly is not spread out at all, right? That's just a bunch of ones. It has no variation at all. It's the same number over and over again. So we know it's not these two with the greatest standard variation or standard deviation. This one's pretty spread out. 1, 2, 3, 4, 5, 6, right? It has all the numbers and only a little bit of each one. So I would say number 2 is ruled out. But the one with the most variation is this. And if you think about plotting that, you'll see why. Let's just make another one of these number lines. I find these very useful. 1, 2, 3, 4, 5, 6. And we say, how spread out is the data? Well, let's plot it. 3 1s and 3 6s. You literally can't get more spread out than that. So if the question is, what's the greatest standard deviation? You look for the data set where the data is the most variable, right? If this question had said the least standard deviation, you want to look for the data set where the data is all clumped together as much as possible.